we're going to be doing an example of how to write a chemical formula or chemical equation for an electrolytic dissociation. This time we're going to be determining the chemical equation for the electrolytic dissociation of the solid sodium nitrate, or NaNO3. The first thing I've got to do here is, of course, write the electrolyte in question, which is our sodium nitrate. So NaNO3 is going to be put here. It is in solid form, so I want to make sure that my phase is written as a subscript beside. And then I'm going to be preparing myself to write my cation and my anion to the right of the arrow. Now, in this case, I have my sodium as my cation, and I have a polyatomic compound here. So polyatomic ion right here. So the NO3 is going to spice things up a little bit for us. All right, so first of all, before I go any further, I just want to make sure that I get my correct phases. So they're both in aqueous phase. So I'm going to put that in right away so we don't forget it. That's often a step that is forgotten. And after that, I'm going to take a look. Because it's polyatomic, I actually get to look this up on a table. Your teacher may have provided you with one already. You can see here that some of the common polyatomic ions have been listed here. And the one that we're interested in, of course, is the nitrate. So it's got a -1 charge, as you can see, according to our table. So I'm just going to add that here to my ion. Next, sodium is not polyatomic, so I can just get that right off the periodic table here. And you can see that it's part of the alkali metals at the end. So that's group 1A. And so it tends to have a charge of +1, which I just write as plus here. Now, I want to check and make sure that everything is balanced, and so that I don't have any coefficients that I need to be putting in there, and everything looks okay. I've got 1 sodium, 1 nitrate, so all I need to do now is make sure that my charge is balanced. So taking a look at this, I have a +1 for my sodium. So I'm just going to write 1+, and I'm adding that to a -1 for my nitrate. And so overall, this gives me a charge of 0, which is exactly what I'm hoping for.